the distributive property. And used with situations where we have multiplication and either addition and subtraction. For example, this situation, 6 parentheses 12 minus 2. Okay. Now there's two ways to do this. If we use order of operations, it says to take 12 minus 2 and you get 10, and then you multiply that times 6 and you get 60. Okay. Or we can distribute this 6. Okay. And we're going to use multiplication to do that. So I like to put those little lines in there to signify where my 6 is going to be multiplied. So this says that the 6 needs to be multiplied by the 12. And I'm going to leave my minus sign in there. And the 6 needs to be multiplied by the 2. Okay, and now if we evaluate, we should end up with the exact same answer we were getting the other way. Let's see, 6 times 12. 6 times 10 is 60. And 6 times 2 is 72. So, yeah, 12 and 60 is 72. Minus 6 times 2 is 12. 72 minus 12 is 60. So that one we distributed, rewrote, using distributive property, that would be this portion, and then evaluated. Okay, the reason we use this is not for a problem like this, but for algebraic expressions. Okay, so if we have a situation like this, 5g minus 9. Okay, now it's a little more unclear what g minus 9 is, so we're going to distribute. And this could help us solve this problem, or at least give us a better idea of what to do with our g. So now I have 5 times g, which is 5g, and 5 times 9, with my minus sign still in there, which is 45. Oops, parentheses. Right. This one cannot be evaluated because we do not have a value for g. Okay, that's the distributive property. Okay, we've already talked about what terms are, so let's talk about what like terms are. Okay, like terms are terms that contain the same variables with corresponding powers or exponents. So terms that contain the same variables with corresponding exponents. Okay. Oops. Read that up there for a little bit. Okay. So, examples of like terms. 2x and 4x are like terms. That's like having 2 apples and 4 apples. You can combine those. Okay. 3x squared y to the 6th and 7x squared y to the 6th. Notice that the coefficient doesn't have to be the same, just that the powers on the corresponding variables have to be the same. Since my first x is squared, my second x has to be squared. And since my first y is to the 6th power, the other term has to have a y to the 6th power in it. Okay? Those would be like terms. Okay, to combine these, we replace these ands with plus signs, because that's what and means in math. Okay, we could combine these. 2x and 4x is 6x's, and 3x squared y to the 6th and 7x squared y to the 6th is 10x squared y to the 6th. Also notice when I add like terms, the powers on my exponents do not change. Okay? So let me give you a non-example of a like term, just so we have one out there. Five x squared z to the third and 5x z cubed. Okay? Very close to the same, but since one has x squared and the other has just an x, they are not like terms. Okay, let's look at one example of how to use the distributive property to solve a more complicated multiplication problem. Okay? So if I have something like (16 times 102), okay? Now I could go about long multiplication if I wanted to, or I could split this up. Okay, I know that 102 is the same as, I'm going to replace it with an equivalent expression. So instead of 102, I can put 100 plus 2. Okay, and now I can rewrite that using the distributive property, which would be 16 times 100, which is pretty easy to multiply, plus 16 times 2, which is also pretty easy to multiply. 16 times 100, that means take the 16, you add 2 zeros to it, so we have 1600, plus 16 times 2, which is what? 32. So 1632. Okay? So this makes multiplying larger numbers easier to do in your head.